All right. We'll be going. This is lecture 3 now. We'll talk about localized, delocalized, hyperconjugation, inductive effect, and charge transfer. All right. So be able to explain everything and have a clear understanding. So without wasting our time, let's go. Okay. So in each bond that you see, that you be able to see in these molecules, organic molecules, all right, so we have localized, delocalized chemical bonds, so they will be of two. So a chemical bond is a connection between two atoms, so it's actually a bond or the attachment of two or more atoms. Okay, so connection occur due to overlapping of molecular orbitals. So we have, let's say, oxygen reacting with oxygen to give what? O2. So the overlap of the orbitals will overlap like this. All right. Now should I demonstrate this? Let me show you. So for you to actually, we remember we used to play a game like this, whereby someone will stand there, and also let's say a girl will stand there. All right. Okay, so these they will use two lobes, so they will make a bond by overlapping their hands. Suppose, so even these atoms, for them to be together, all right, they have to overlap like that. All right, so they have to overlap like that. So this is the bond that they have formed also, just like these human beings. Okay, you remember the game? So that's how the bonds are formed in these organic molecules. So there are two major forms of bonds as localized or delocalized chemical bonds. So let us now describe the localized ones. So in those molecules, we'll be able to see localized bonds and delocalized bonds. By the way, localized simply means you are located just within the local. So you are not moving anywhere, all right? So a localized chemical bonds are normal bond, sigma bonds, all right, or pi bonds, or lone pair electron pairs, that is electron pair, that exist on a single atom, all right. Suppose I have now the bond of carbon, all right, and hydrogen there. Okay, so it can be the lone pairs which are here that can't go on this atom, so they can't conjugate. By the way, conjugating is something like we are just trying to change because of the environment, trying to balance our environment, and we conjugate, we change the system. Conjuging is something like changing, all right. So we can have lone pair, which are these, they can't go to this atom, so they are localized on this carbon. Again, we can have a pi bond, all right. Pi bond, always they are sideways like this, they are not frontal like sigma. So even these, they are localized on this because this can't possess that type of a bond. They can't possess the overlap, which is the sideways, but the frontal one. So hydrogen, this bond, which is the pi bonds, can't actually associate with this hydrogen. So, and also a sigma bond. So when I say a sigma bond, now we have hydrogen there. So this bond, this is just within this, it can't go this side, all right. So that is what we mean when we say localized. It's just locally located within the carbon or within that single atom. All right. So we can see these two bonded atoms. All right. The bond that is between there. All right. It is just local. It can't move anywhere. The sigma bond that is there, it can't go anywhere. Okay. It's not associated with any atom, but just within the single atom there. So with a single atom there, please. So that means we can have, let's say, carbon dioxide, let me say O2 or N2. The bonds, the those lone pairs will be only associated to this one. Okay, like we have N bonded to two like this, then their own pair there, their own pair. These, they are just associated, they can't go to this one. Why? Because even this one has also the same problem. So that way will be actually a very difficult stuff for it to conjugate. They won't conjugate, they won't get transferred to another trying to stabilize the molecule. The molecule will still remain unstable. All right. So in short, in summary, know that a localized chemical bond is a bond that it's a bond of sigma. It can be also of pi, which are overlap, and also the lone pairs. All right, that only associate or exist on a single atom. All right. So that's what we mean when we say a localized bond, chemical bond. We even find the type of electrons called localized electrons. All right. So let us see. Let us see again what is the other type of bond. So now we'll talk about the delocalized bonds or chemical bonds. All right. So when you say delocalized chemical bonds, are the chemical bonds, all right, that do not associate. Please master the keyword associate with with. Okay, I'm saying delocalized chemical bonds are the chemical bonds that do not associate with only a single atom, but with several atoms or other chemical bonds. So we can we call these electrons found as the localized electrons, and we'll start more. We explore much on complex, okay, sigma complex, where we'll see the electron conjugating from one sigma to another, trying to stabilize the molecule because of carbocation that we'll see on a specified carbon. So delocalization occurs in conjugated pi system. Let us say only. Let me put only so that you don't get lost. By this, I mean we know benzene ring, or even if you don't know, but benzene ring looks like this. All right, it has what? Six conjugated system. All right, so it has alternative double bonds like that. So there's this bond that you are able to see here. This bond can alternate to this one, and this one can come to this one, and also this one can come there. You have seen, that is what we call conjugating, like moving from one place to another, just trying to see the environment around it, and also if it can find a stable place, okay? Because these electrons are not happy where they are seated mostly, so as they try to move from one place to another, they are trying to stabilize the system. That's the reason why in benzene we put a ring, because these electrons will be rotating like repeatedly with this manner. All right, so a conjugated pi system is this one. I said to say the pi bonds will be rotating like that, will be alternating pi single, pi single, pi single, pi single, just like that. Okay, so they will be rotating pi single, pi single, again pi, then single. All right, so that's how they will actually be rotating like this. So we call it conjugated system because it conjugates from one place to another, trying to stabilize. So delocalized chemical bonds, these are bonds that do not associate with only a single atom, but with several atoms or other chemical bonds. Or you can end here with several atoms. That's enough for you. You get me? So we can see now, let me show you the conjugated system I'm trying to talk about. So this system is conjugated, where we see this alternating bond can also be attached there, and also this can be attached there. Okay, it changes. Why? The reason is all these molecules, they are trying to stabilize. So you find that even you, as you are trying to find a good rhythm, you'll be able to move from one place to another. So even these electrons, they do the same. So they'll be shifting from one place to another, trying to stabilize. They want to be stable as well, just like you are here studying, because you want to have that future you are expecting. So that applies to these molecules. Electrons are like human beings. That's what I was saying, because that's how they'll be behaving. So localized versus delocalized bonds, what are the difference? A chemical bond is a connection between two atoms. We have explained this. There are two types of as localized and delocalized chemical bonds. So the difference comes as between localized and localized is that localized chemical bonds is a specific, all right? So it is a specific, whatever. Okay. It's a specific, all right, it's a specific or a lone electron pair on a specific atom, whereas a delocalized chemical bond is a specific bond that is not associated with a single atom. So for localized, it's associated with single atom, but for delocalized, it's not associated. It's not local. That's the it's opposite of local. So this can move from one place to another, from CBU to Unza, and from another university to the other university. Okay, so that is it. So hope you're able to get the difference now. You can even define now. This one associate with a single atom, the other one do not associate with a single atom. So that actually marks the difference. That's the major difference you can experience. Then from there, we'll be there now talking about inductive effect. So what is inductive effect? Suppose you have two molecules, carbon and hydrogen. Then we expose some, I don't know if it's temperature or whatever, but this is just spontaneous, random like process happening to say we are now separating these two molecules, I mean atoms bonded. So we are there to polarize. Polarization simply means formation of positive and negative. So we'll be there to actually break this bond, and the other one will carry, let's say, a positive, and this one will carry a negative, depending with how electronegativity it is that atom. So where this is partial, it's not permanent, by the way, because it's just the moment, let's say you break the atom, yes, the molecule is broken, then this thing is like, it does happen, okay? Even in water, it does happen. When you boil water, the polarization do happen there, but you don't know, sometimes it could be the source of heat. So let's go, a polarization, inductive effect, the polarization of a bond, okay, due to electron withdrawing. So you remove an electron, so electron donating effect of adjacent groups or atoms is referred to inductive effect. So between two atoms, you actually withdraw an electron, one electron. So you find that this one will get, let's say, negative charge, the more elective, this one positive charge. These are partial, all right? Partial charges. When you say partial, it's not completely, so it can be reversed. The electronegativity, atoms get partial negative, all right? The more electronegative elements, it will get negative charge. So if it's carbon, it will get partial negative, all right? Then the less electronegative, it will get partial positive, all right? Okay, so the more electronegativity metal, even the arrow will point to the more electronegativity metal. So that's what we mean. While the atoms gets partial positive, I mean, while the other atom, which is less electronegativity, get. So we have now CH bond as an example. Practical considers non-polar. When you say it's non-polar, meaning that um, we have a dipole moment existing there. Because if we have H to H, this is polar, all right? So non-polar will have a dipole moment. All right. So meaning atoms are different with different negative, I mean electronegativity charge. There is a partial positive charge on hydrogen, and partial negative charge on carbon, and the carbon that will be negatively charged will be called a carbanion. All right, carbanion is when it's an ion, and carbocation a positive ion. So you master them like that. Carbocation is when carbon forms a positive, carbanion when carbon forms a negative, like that. Okay, so we'll be able to see when we withdraw one hydrogen. For suppose we have a methyl there, so that's a methyl, all right? So a carbon bonded to only one carbon will be called a primary carbon, okay? Then that one which you bonded to two carbons, other carbons is called, then three, it is called tertiary. Okay, just like that. So we are now here to actually remember the stability. The stability comes as the more with more carbons around it. That carbon with a carbocation with the, we say decarbocation is it's a process where carbon acquire a positive charge or have a positive charge. So this carbon is positively charged. That means, and how many carbons are connected to it is only this one. So it will be primary carbon. All right. Then a carbon, this carbon, which is a carbocation that is charged, that has two carbons, other carbons, is called secondary carbon. Then the carbon that has three other carbons is called the tertiary carbons. Okay, so the stability increase just like this. So the stability increase as you have more friends. These friends, they can hyperconjugate, they can donate other electrons to this lacking one. So they can share. They can be a partial sharing of these electrons, and we call it hyperconjugation. All right. So the stability is more like you have more friends who are rich. They are rich. Okay. You also have money. So that is, but when you have poor guys, you also you'll be poor because you pray, you think together, you make programs together that of poor people. Yeah. So that is it. So the more the carbons around the carbocation, the more the stable it is. So you can less the stability of this primary, secondary, then tertiary. So it increases like that. So pay attention to the stability, very important. You'll be asked the stability order. So make sure you know. I've explained the reason why, because you associate with a lot of people, you'll be also rich. I've explained this. All right. So now we talk about now hyperconjugation. So this is the one I was talking in the previous, to say electrons will be alternating, trying to actually stabilize the molecule. So what will happen is that a hyperconjugation is the overlap, all right, of a sigma bond. This is a sigma bond with adjacent empty or partially filled p orbital, or even a pi orbital. All right. So it can be a p filled or partially, then or pi orbital, to give a delocalized or to stabilize the molecule. All right. So only electrons in the bonds that are beta carbon. So a beta carbon is the carbon that is what? That is next to the carbocation. Suppose we have carbocation there, then the next is called the beta one. All right. Alpha carbon is the carbon that is just to the, let's say we have a functional group. This will be a alpha carbon. So a alpha carbon is a carbon to the next to the functional group, and this one now is the second carbon, right? So it will be beta carbon. All right. From there, this carbocation. All right. So that's what will happen. So please remember to say hyperconjugate is just the overlap of what? Sigma. Suppose we have carbon and carbon there, carbocation there, and this carbon. So it's bonded to some bonds there. So there will be overlap of this adjacent to this one. This is a partial, all right? So a bond, a sigma bond, you have seen, with an adjacent. So this is adjacent, empty or partially filled p orbital or pi orbital, to give a delocalized. So the electrons that will be involved in that bond of p overlap with that which was there, it will be delocalized because it can go back there. It's not permanent, say partial process. Partial process, all right. So only electrons in bond that are beta, like I said, to the positive charge cation. So if it was a functional group, that positive charge carbocation, it would have been alpha carbon, like I explained. Take part in hyperconjugation. Only that the third one won't be considered in this carbocation. So hyperconjugation explains the stability. So the more carbons we have bonded to that carbocation, which is positive carbon, the more the stable the molecule will be, as in this order, please. So we can see now, let me just explain this. Let me explain this. So what is happening here is that we have p orbital there, right? Remember this carbocation, it has it has a positive, right? It's lacking an electron. It gave when it was done by inductive effect. Before that, let me explain here. This is inductive. There was a hydrogen there, but it was removed. You see, then the hydrogen acquired a negative charge. Then this one a positive charge. So that means that the carbon now remained with what? With this positive charge. So only this carbon can help. You have seen So the adjacent carbon that we can get here is, I can get this one, all right? Or this one, okay? That's why you say in take part in hyperconjugating. Hyperconjugating, we are trying to see this one can donate, this can donate. All these are adjacent carbons. So what we are going to see is, let's get this adjacent carbon, all right? What will happen is that the Z is bonded to 3 hydrogen, right? So what will happen is that this carbon which is just there, it can be written as like this, is lacking. So the p orbital can overlap within this, right? So we have there. So it can be this side adjacent or this side. So we go to the carbon that is now stable. All right. So see now what will happen. These molecules that sometimes they are dull, they are not smart. So we have this sp3 hybridized. It was 1, 2, 3, 4. We explained about sp3 hybridized. So this now, this carbon here, which is adjacent, can try to give that guy, give a positive, and it will be stable. So this hydrogen which is here will come there partially, it will bond there. Okay, and here again, this damage which was here, it will come there. It will be positive charge a bit as well. So they are doing this in a partial way just to stabilize themselves. All right. They are doing this just to stabilize themselves. So this is now the weak overlap that we are able to see. This hydrogen is trying to overlap. So the hydrogen will come and overlap there in a weak way. Okay. So the direction will be like that, trying to stabilize this. And here again, it will create a bit of positive because it went with electrons that it donated there to make this, to kill this. Okay. So that is the carbocation hyperconjugation. Like the hyperconjugation only happened, let's say we looked at in a benzene state where these electrons or delocalized electrons, they will be rotating. Even here, they are delocalized electrons that we are using. So they are not specific on a single atom. They can go to this. They don't care. Okay, they are prostitutes. So they are prostitutes. Okay, so if you can sleep with 10 person, you don't care. Eh. So that's not good. Anyway, you stabilize trying to look at like a better girlfriend, stuff like that. We understand. So that's what happens. So from there, then finally, let's talk about the charge transfer. So a charge transfer, also called electron donor. Why? We donate electrons to the lacking atom or a point or whatever things that we can charge. So um it's an also called electron acceptor, right? Donor, I mean acceptor. So can be defined as association of two or more molecules in which a fraction of electrons, suppose we have 20 or 10, 3 electrons, then let's say one electron is shared due to induction or conduction. I'll explain all those. So a fraction of electron charges will be transferred between two molecules or entities. Then we also observe that suppose you are now combing, right? And you get that comb, try to lift say paper. You charge the paper by, after you comb your hair, you are combing your hair, you are combing your hair, you are combing your hair. All right. Then from there, you find that electrons will be transferred. That's now what? That's the conduction. You are conducting because of physical scrubbing. So by this, electrons will be transferred. Okay, you will charge the metal which was, or the substance which was neutral. It will be given. Suppose you have electrons on this surface. Then you are charging, you are scrubbing this. You find that also this will get some partial electrons. As time goes by, the electrons will go to the ground, trying to set this equilibrium of diffusion, because the higher the electron density also actually contribute trying to stabilize the whole system. So electrons will start moving there when you charge them to the neutral uh, substance. Okay, so they will decrease slowly from the source, then they will decrease slowly. So you get this point. We normally do this in our daily life, but we don't just recognize this is what happens. So can we guess why this happens? Why where does the charges go? Time, where does it go? We can say that the charges get transferred to our hands, eventually to the ground, finally, then the substance will come neutral again. Okay, it's just it's not lasting. It's just a temporal stuff. But how does this phenomenon occur? All right. I'll leave that for you. How does that occur? It's because of these charges. Okay. So now from there, let's talk about the types of charge transfer. So before that, we can, which are methods or types. So I'll define it again. A charge transfer is the process by which electrons move from one thing or one atom to another. Okay. So like I explained, we can get molecules. In this case, we'll be dealing with molecules. This is organic chemistry, right? So there are two methods through which charge transfer can be done. The first one is through induction, conduction. So when you conduct something, we involve physical touch. Okay, suppose this instrument or magnet, it has magnet, right? Then you bring just any metal there, and this is magnetic material, or this is magnet. All right, so you find that all these charges in the magnet, they'll be, you trying to I mean, you get, let's say, a screwdriver, you put it there on the magnet for a long time, just you wait, let's say, for 1 minute. The electrons that will be there will be conducted. That's what we call conduction to your screwdriver. All right, to your screwdriver, and you'll be able to lift, let's say, a screw, which was, let's say, that you want to put, to tie something, to screw something. So that's what we call conduction. So you conduct by physical process, or you attach this physically, then you'll be able to actually elicit some electrons. You'll be able to collect some electrons because of high density of electrons there. Then they will give magnetic property there to your screwdriver, and you'll be able to lift your what? Your screw using the screwdriver. The beans there. Beans. Is it okay, beans? On the fire. Is there water? Okay, so that is it for conduction. And also charging by induction. It's a situation whereby you just bring something by inductive manner, like we just use wave here. Okay, you bring nearby something, or most of these people who are studying electricity, they can tell you to say, yes, when you just bring close something that is charged, if the high density of electrons is very high, you bring something here. Okay, even this thing will be charged. Just try wherever there is a transformer, and you get some like you get some metal stuff like that, you feel that the electrons will be charged to that metal you have, and to actually have a you'll be shocked a bit, electrocuted a bit. So that's what happens. So that is induction. We just bring close, not really physical contact, but just close, and the electrons will be, it will be charged, this thing. And this actually happens in yeah, electrostatic can happen even in under induction, especially whereby the electro the electricity that we have is just static, like it doesn't move anywhere, it's just within there. So we need some bit of what, conduction and induction there, depending with the amount of electricity we have, or electrons that we have. So that marks the end. Thank you very much. So actually, these are the things you need to know how to define hyperconjugation. All right, so we said what is important here is to define it. Let me say, I want you to know how to define inductive effect. We are just trying to create a polarity within our molecule bonds. So we break that, partial breaking, then this we can get, let's say, negative, then this positive. Okay. By this, when a carbon is charged positive, it's called carbocation. When it is charged negative, it's called carbanion. So inductive effect is the polarization of a bond, a sigma bond. Please, a sigma bond, that bond that was there between two, due to electron withdrawing or electron donating effect. So there is this one which can withdraw, is called withdrawing. Then this one is donating because it's give positive. Okay, due to electron donating or withdrawing. Okay, groups. So there are two groups in a bond. The other one can be withdrawing, the other one donating. So that will be referred to as inductive effect. Hope that marks the clear picture of inductive effect. Then the other thing that I want you to know is hyperconjugation. Hyperconjugation is the overlap of bond, okay, sigma bond. It will overlap with an adjacent, all right, adjacent p, or a p orbital or pi orbital that is partial or completely filled, all right, to actually give a delocalized electrons. By delocalized, it means the electron can rotate forth and back. It can go this side and also this side, creating the same problem which was here. It will solve this problem which was there, and also it will create the same problem here where it has come from. So that's how these molecules, they all do this because they want to stabilize, stay stable wherever they are. Electrons actually repels each other, especially if they are having the same spin. So that marks the end of actual lecture 3. Thank you very much for your time. Follow the playlist.